So anyway, I'm Sounil Yu. I work for a small bank, starts with bank, ends with America. Um, but I'm kind of incognito today. So anything I say here, I have a bunch of disclaimers, the standard stuff. But the main disclaimer I'm going to give is this notion that the model I'm going to show you I know is wrong, okay? But ultimately it's about being useful. And I've thought about this model quite a bit, and ultimately I wanted to share it with you guys because I think core to what we're trying to do here in terms of moving from art to science is to start with a model that says, here's what we do. And if we don't have that model, then we're just talking past each other a lot. So this is just a primer for like, why do we need a model and what does a model need to have? I'm not going to read through all this because it's a lot of text. I provide this as reference. Later on, we're going to hit each one of these as we go. So the reason why I entered this problem was because in the role that I serve within my institution, I see a lot of, I do intake for all the startups and all the security technologies that come my way. And so I needed a way to be able to process that. And unfortunately, this is not a great model for how we do cybersecurity. It's just a bunch of buzzwords that the marketers come throwing at us to have us go buy their products. So instead of this sort of construct, what I did was I came up with a more simple construct, one that consists of two dimensions. On one dimension, things that I care about. The other dimension, things that I do. You put those two into a matrix, and you get the cyber defense matrix, which everyone should have gotten on their chair. If you don't have one, certainly let me know or grab the one that's next to you. But the basic construct of the model then is this 5x5 matrix. Now, there's one of the key things that we want to be able to do in having a model is to be able to allow us to communicate with each other using a common shared mental model of a certain phenomenon. The phenomenon being cybersecurity and how we do cybersecurity. So this 5x5 matrix, hopefully is easy to remember. The one dimension is in this cybersecurity framework, which if you haven't already committed that to memory, you should. The other dimension are things that we care about, which again, are fairly intuitive. But some of the words don't necessarily always make sense. So for example, let's use the word identify versus the word detect, okay? Raise of hands. How many people would say you identify vulnerabilities versus detect vulnerabilities? So who says identify vulnerabilities? Okay, who says detect vulnerabilities? All right, the very simple fact that we have difference of opinion here is a problem, right? Okay, how long is a meter? If I got a meter and said, here's a meter stick, would everyone agree that's a meter for the most part, right? No one would disagree that a certain definition of a length of wire is a meter based on how we measure it, or how long a second is, or how much something weighs. In our field, we don't have that, we haven't normalized that. And so it's important for us to normalize what we mean by these different terms, okay? And so in that context, one of the things that we can use within the context of the matrix is say, look, if something is happening left of boom, then it means certain things. If something happens to the right of boom, it means certain things. So the boom happens between protect and detect. Okay, boom is somewhere in between that threshold. Everything before boom is before the event happens, and it gives you structural understanding. Okay, it gives you structural awareness of your environment. So structural weaknesses, like vulnerabilities, then happens on the left side. Okay, you identify vulnerabilities, and you do something to protect yourself with those vulnerabilities. When boom happens, and then you are looking for somebody who's exploited that vulnerability, you're not detecting vulnerabilities anymore, but rather you're detecting essentially an intrusion or an exploit against that vulnerability. All right. So just having that sort of clear understanding of what are we doing on the left, what are we doing on the right, what does the term identify mean in this context, what does the term detect mean in this context, that's an important facet for what we're trying to do here. And again, ultimately, the point of the model is we need to be able to communicate with each other clearly and have this shared model, okay? We can't be confused about what we mean by identify versus detect. All right, so when we look at the model now, one of the things that I'm trying to do ultimately is prove that the model works. And one of the ways that you prove that the model works is actually by providing falsifiable information. So I want to throw information at it and say, well, maybe this won't fit, right? Well, and if I can't fit it, then I know the model's wrong. Well, one of the ways that we want to do that is by looking at this buzzword soup here and say, can I fit everything in here into this matrix, okay? And so when I do that, I get this. All right, so I tried to fit as many of those buzzwords in here and see if I could fit all those different terms. And I was able to fit a lot of it, but I couldn't fit everything. Okay, so I said, okay, my model, it's incomplete. There's something wrong with this model. But what was interesting is just that this model, by mapping it this way, it helped me understand that there were connections that I didn't realize were connected, but that were related. And I'll talk about that a little later. But this notion of a model should show us things that we didn't realize were connected to begin with. All right, we'll reveal that a little later. When I looked at the model, though, and I said, okay, I can't seem to fit, for example, a fairly obvious one like threat intelligence. All right, I couldn't fit threat intelligence in here. Into this framework. And I realized the reason why I couldn't do that is because the matrix as we have it now, at its core, it's showing you what we care about, but it's stuff that we own, okay? So we own enterprise assets, that's why I care about it, but I also care about assets owned by other entities. I care about assets owned by employees, by customers, vendors. I even care about assets owned by threat actors. And when I look at assets owned by threat actors, that's when I get threat intelligence. So we end up with the identification of threat actor assets becomes, I actually try to avoid the word threat intelligence, I call it threat data. But if you consider, for example, what is a threat actor application better known as? It's better known as malware, right? And what we want to do is basically have capabilities that help deconstruct what a threat actor application is and understand what that is for us. For vendor assets, we may want to, for example, extend our security controls into a vendor application, sometimes better known as cloud or SaaS. And so there's a bunch of different technologies there to support that. If I'm looking at companies like BitSight or Cybersecurity Scorecard or Risk Recon, they're doing basically a assessment of the vendor's attack surface and helping me understand whether or not I want to continue doing business with them. And so on and so forth, all these different other dimensions. So the point of this is to say, within the context of a model, the first model that we started off with is incomplete. And I looked at it further and I realized, okay, I'm missing something that I couldn't fit the observations into the model, and thus I said, okay, I have to expand the model. But the model still has to be coherent and still have to fit everything else as well, right? It has to be able to match the observations that we see elsewhere. So I start with this, and then if you flip to the back, you end up with the next dimension, if you will, that captures the other parts of what I saw in the technology space. But the technology, I should also mention, so then I mapped everything to against the domains. I mapped everything against operational functions. One of the things I noticed when I was mapping things against the operational functions is something that you'll note back on this slide, which is this degree of dependency on people, process, and technology. So I determined this through observational evidence, but the notion that on the left side of identify, protect, and detect, there's a stronger dependence on technology. On the right side, there's a stronger dependence on people, with a roughly equal amount of process throughout, okay? And the evidence that, I forgot what preceded one, but the point is that when we look at this particular layout of, this is also very much selective, so this is not the whole universe of vendors as you may expect. But I just took a whole bunch of vendors that I could find and said, okay, where do they fit? And it just happened to naturally fit into this construct where there's a lot of technologies up here. What do we see down here? We see a lot of body shops. You see people who are going to basically deliver people, right? People with skills to go and do incident response, hunting, whatever else it may be. So the point of this is to say, okay, we have a model. I'm going to make a prediction. In this case, the prediction was based on, well, the observation of this degree of dependency was based on what I saw in technology. But the prediction is, we're going to see, we should see, for these particular activities, we really should be seeing a higher dependence on people to do that work, okay? Again, that's a prediction that I said I would make, And then subsequently, we want to see if the observational evidence matches that as well. All right, so you map it against the matrix. Again, selective set, so it's not a complete set. But anyway, so far I've talked about it from a technology standpoint, but I'm going to now switch gears and talk about it from all these different phenomena that we can observe in our space, and then ultimately how it maps back to how the model helps us understand that phenomenon better. Okay. By the way, everyone tracking so far? Okay, good. All right. So the first phenomena, this is security is a very complex topic, right? The space that we operate in is very esoteric in many ways, but being able to deconstruct it makes it much easier. Being able to deconstruct it into its component parts. So as a really simple example, when we look at, for example, threat data, okay? The function of threat data, the primary function of it is what? It identifies threat actor assets, okay? If you read the marketing material for a bunch of threat intelligence providers, what do they say they do? They say that they'll protect you from attacks and help you detect intrusions and slice your bread and butter your toast and so on and so forth, right? Okay, but the first order effect is basically just identifying threat actor assets. The second order effect is doing all those things that the marketing literature says, but it requires a first order function to make it happen. Okay, so the first order function, there are things, enterprise assets that, things that will help either protect or detect things within your enterprise assets. So if you don't have this first order function, then it doesn't matter what this does for you because you're not going to be able to implement it, right? The threat data by itself isn't going to protect you. The threat data by itself is not going to detect any intrusions. So being able to decompose our functions into first order and second order effects is something that we're trying to do in the context of using this model. All right, phenomenon number 2, alignment of roles and responsibilities within our organization. So one of the things that we oftentimes struggle with is, within security, well, whose responsibility is this? Is this IT's responsibilities? Or is it security's responsibility? Is it the network engineering folks, or is it ours? Is it HR's, or is it ours? One thing that we observed, so first of all, in the context of what identify is, I'm going to just pick an example of one particular function, the function of identify. There's 3 things that we primarily do in identify. We establish an inventory, we prioritize an inventory, and we measure that attack surface of that inventory. Okay, that's a basic function of identify. The whole notion of establishing inventory and prioritizing inventory and measuring attack surface, it turns out that who does what turns out to be fairly consistent regardless of who your business partners are, okay? So your business partners, for example, in the device space, is going to be probably like some group that manages workstations. Okay, well, the establishing the inventory and prioritizing it is still going to be the responsibility of whoever manages that function, okay? But the measurement of the attack surface, we often find that security takes responsibility for that. And then, but the accountable party is still the owner, okay? And we consult the owner before we scan something, and we inform the owner afterwards with the results of whatever we found, okay? And this happens, the most obvious examples are the ones that we know of, but let me just apply it against users, because users is an interesting concept as well. So who inventories your users? HR, right? Who gives you a prioritization of those users? That's usually some sort of hierarchy based on the roles and responsibilities that they have. Who does attack surface measurements? All right, well, the whole notion of background checks would be an example of how you measure somebody's attack surface. There's another way that we do it, which is we simulate phishing attacks, and we figure out how likely they are to click on something, okay? But the function of those things, it turns out security tends to run with those, all right? And one of the predictions I make here is that, is it more efficient or inefficient, rather, is it inefficient when something is out of whack, okay? It appears that the ownership of these functions appears to be consistent across different domains. When you're inconsistent, is it inefficient for your organization, okay? Also, in the context of that people, process, and technology dependency spectrum, if you are doing stuff here that is largely people dependent, meaning you have somebody with a clipboard walking around, or the equivalent of a web-based clipboard walking around, asking people to inventory your applications, all right? If you have that type of function that's happening, then it's going to be highly inefficient for obvious reasons, but it's also going to be really poor in terms of the data quality, okay? It's going to be incomplete, it's going to be out of date. You can imagine that same sort of concept of background checks. We only run background checks when you first join an institution because it's very labor intensive. And there's a number of companies out there that are trying to make that faster and more automated, right? But that as a problem set is that we're basically saying we really have a huge dependence on technology. We should have a larger dependence on technology, but the technology hasn't kept up, or we haven't chosen to use the technology or to buy the technology to do that for us. All right? So then, when, in terms of alignment of roles, there's another perspective, which is in terms of how we look at security. There's various functions that we have within security. We have vulnerability assessments here. We have vulnerability management here. We have a SOC function here, incident response. And some security functions have BCP and COOP as a part of it. I think at my organization, we kicked them out a while back. But if you think about the whole spectrum of what we're trying to do, maybe it actually does make sense for them to be, or at least part of it, to be part of the security function. One thing that I want to point out here is that the notion of it transcending across all these different domains, it's important to think of it in that sort of construct. So for example, I mentioned the users and the vulnerability assessment of users around background checks, okay? Well, let's take protect for a moment. How do you protect somebody from phishing attacks? Well, the way you measure their attack surface is by looking at how often they click on a phishing email. But the way that you patch that person is by giving them phishing awareness training, okay? You patch somebody through phishing awareness training. Who actually runs that function? Right now, security runs that function, but training awareness is a HR function. Should HR actually be running it instead, informed by information security? The SOC traditionally has looked at devices and networks, but should it also include insider type of activities as well, okay? So this notion of thinking it more broadly and saying we need to really cover these different domains beyond just what we traditionally do, the model tells us where we have gaps potentially in our space. And then I mentioned earlier this notion of business partners, who you work with. And it turns out that on the horizontals, we have different partners that we interact with, and they have shared responsibilities in some of these spaces. So, for example, who patches your machines? Information security usually isn't the group that patches the machines. It's the owner that patches the machines. But information security sets the policies and the guidance around, hey, you need to patch within certain timeframes and so on and so forth. Well, again, the notion of patching a machine versus patching a person, okay? Or properly securing your data or whatever else it may be, or fixing your application, that function of protect, again, seems to line up with who owns that particular function. So the whole notion of using this model then to see how does our organization align up with the model? Are there potential inefficiencies based on where we have divergence from what the model suggests? All right, so that's phenomenon number 2. Number 3, this one's a very complex one. So let me walk through this as quickly as I can, but as efficiently as I can too. So when we think about the model, it reflects a couple of different factors. One is what we're trying to secure, okay? So you can look at the model from one eye and say, okay, this is what I'm securing. If you look at it from the other eye, it talks about where we secure it, all right? So what I'm securing is applications, but where I secure it may be in different places. There's a couple different ways to secure applications, whether it's runtime application self-protection or a web application firewall or secure coding practices. But where you do it may be different, okay? I may, in one case, do it on applications, I may do it on networks, or I may do it on the user. And there's a bunch of different vendors that will help you deploy or fix those type of problems. Same with endpoint. You have a lot of different ways to protect the endpoint, a lot of different places where you can protect the endpoint as well, and with a lot of vendors that follow. But let me dig a little bit further on this and talk about some predictions that we might have based on this. So when we think about what our deployment options and choices are, first of all, the notion of having options for deploying in all these spaces tells us, hey, do we have a solutions gap here? How come I can only deploy on device, network, and users? What are my options or opportunities to be able to deploy in applications and data? Okay, what we're starting to see emerge in the marketplace are companies that are actually trying to tackle it from that angle, which I think is kind of interesting because it's filling out the rest of the matrix, if you will, or how we look at the space. So understanding that there are opportunities to deploy in other parts of the domain. Now, the caveat, though, is on the efficacy side, I would make a hypothesis that efficacy is higher for protection when your what equals your where, okay? When your what equals your where. So if you're trying to protect your endpoint, where you deploy, if it's on the endpoint as well, then you have the highest efficacy, all right? So you're trying to protect your endpoint, your highest efficacy will be when you deploy your protections on your endpoint as well. However, when it comes to detection, all right, it's the opposite. You won't get as much efficacy if you deploy it on the same, if you try to detect on the same thing that you're trying to protect, all right? Because fundamentally, if the attacker has bypassed your protections, how can you detect? Which is one of the challenges that we see with a lot of vendors, because they'll say, hey, this same product can do both protection and detection. And how can that be? If you can protect, why do I need to detect at all, right? Let me walk through one quick example just to give you a perspective of how this works. So let's take a network intrusion prevention system. Network intrusion prevention system. Okay, what box is it in? Anyone can yell it out. Network? No, so the box that it's in is network protect, right? Okay? Okay, so anyone who's deployed an IPS in full blocking mode, what usually happens? You deploy it in full blocking mode, about 10 minutes later, you get a bunch of calls, and people say, what just happened? You broke up, all my apps. Stop it now. Okay, so what happens? You go from full blocking mode to just monitoring mode, right? Okay, what box is an IPS in at that point? Detect. Someone says detect. Okay, so all of a sudden, this technology went from network detect to network detect. But how can that be? What I would argue is that instead what we had is a product that went from 100% efficacy in network protect to 0% efficacy in network protect. In either case, it's providing telemetry for detection purposes, okay? But fundamentally, it doesn't change its basic function. Its basic function is network protect. It's either operating at 0% efficiency or somewhere between 0 and 100% efficiency, okay? But the function still doesn't change. So anyway, the point of that is to say, if you have a product that's core capability is to protect, it's not going to be as efficient in the detect function, all right, if it lives in the same space. And then the other prediction that we make in terms of the where is, a lot of times we choose to deploy someplace else for a number of other reasons. And there's a number of parameters that I put forth here to propose why we choose to deploy in other places. One is the ability for that system or that organization to absorb change, okay? So as an example, I would love to deploy lots of controls on my most senior executive, but they are oftentimes the most resistant to change, right? So you often can't deploy things onto that person because they resist change. However, if you operate in a DevOps sort of fashion within an application development team, they are much more apt to change, okay? And thus, if you are trying to introduce security controls or capabilities into that environment, they're going to be more receptive to change and the security, anything that you're trying to do from a security standpoint to that type of environment. So the notion of the ability to absorb change, operational simplicity, and also last, this is a hook for threat modeling. The what we also want to consider in terms of where we deploy is if we create a threat model and look at the different threat vectors that the threat model conveys, we want to consider putting some of our controls where that threat vector is most prevalent, okay? So if that threat vector is through web-based channels and we see that that's going to happen the most, then perhaps deploying on the network makes the most sense. If the threat vector that we see is on the USB, then maybe then the endpoint makes the most sense, okay? So anyway, those are different parameters. Phenomenon number 4, there was a briefing that someone from 451 Research gave 2 years ago at RSA on why a bunch of things that we buy sit on the shelf. So here were the survey results. What I want to point out is a couple of interesting things, and the ones that were the most, that were the worst, okay, and why. And so we see IDS, SIM, and why, not enough expertise, not enough staff. All right, so let's look at the matrix again and figure out where IDSs and SIMs go. Okay, so here's SIMs, here's IDS. What do we see right here? We see that there should be a roughly equal balance of people, process, and technology. What do enterprises oftentimes do when they buy a technology? They put it in and assume that it's just going to work without people, right? What do people complain about? Not enough expertise, not enough staff. So essentially, in this particular case with SIMs and IDSs, they deployed technology, but basically no people. Why is it still sitting on the shelf? Because they didn't have the right balance here, okay? So then predictions. What do I predict? All right, we're going to face that same problem with what we see in emerging technologies that we see today, EDR, UBA, all those sort of spaces. Lots of shiny widgets there. People are going to deploy that technology and assume it's going to work without the people. For those organizations that do that, they'll have the same problems where it's going to sit on the shelf and not provide the value, not provide the value it needs. There's also this notion with respect to the space overall. Again, why are there not capabilities here and here as much? Aviva Latin from Gartner wrote an article recently about how UBA is going to die or is going to disappear. And I actually completely agree. I think the notion is that we saw UBA start here, user behavior analytics. Then they added user and entity behavior analytics to cover this space and this space. But we're seeing other companies emerge that cover this space and this space as well. And essentially, all it is just behavior analytics. And we're going to see a merger of that space. Again, the matrix helps me understand where the gaps are and where we're going to see the emergence of new technologies. If you're investing in technologies in one of these spaces, then it's likely that it'll get disrupted pretty quickly by companies that will basically say, hey, we can also do these spaces, who will then get disrupted or get displaced by companies who say, hey, we can do all of this. All right. And then when we look at that degree of dependency on people, process, and technology again, ultimately, we can look at it to say, look, we don't have technology here, we just have a bunch of people doing this work, and we have technology gaps that we need to fill. Or alternatively, you have situations where you have a machine that generates 50,000 alerts and nobody could look at it, all right? And if you do that, then you get burned. All right, I'm out of time, but I have like a few more slides, so if you can bear with me. A couple extensions to the model. One of the extensions that I came across was this notion of how do I fit in things like what we're saying with identity access management, microsegmentation, perimeterization, even the concept of usable security or zero trust. How do any of those things relate, all right? So the model, again, a scientific model helps connect all these different disparate concepts together, all right? So how do you, again, identity access management, microsegmentation, deperimeterization, usable security, zero trust. Let me show you how they all fit. So when we think about the perimeter today, we oftentimes think of just the network-to-network perimeter. But if you think about it from this to and from sort of notion, then there's actually 25 different perimeters to consider. Then we have this essentially this extension to the matrix that captures that to and from, all right? And so what we see then is a bunch of different ways that we can create perimeters between different sets of assets. What we see in companies like Illumio or vArmor or folks that are trying to do segmentation within data centers, they're saying, you know what, the network perimeter no longer works. I need device to device or device to app or app to device or app to app type of parameters. And so companies like Illumia and VMware and other ones are coming in to basically fill that space. But the whole notion is that we're trying to create more perimeters, and each of these perimeters is like an access control. Whether you call a user access, what you call a access permission for a user, or a firewall rule, it's essentially just another form of access. And what we're trying to do is basically say, okay, what are all the different forms of access, and from whom and to whom are we trying to get it? Now, one of the things is it makes it really difficult for a user if you have to then have to work through all this. But if you remove this bottom part right here, make it as transparent to the user as possible, then you make products much easier to use, okay? And you also adhere to this notion of people-centric security. It's a model that, it's a concept that Gartner pushed out a while back around, hey, trust your users, okay? But then Forrester came up with this notion of zero trust. Where does zero trust fit in that concept? Well, up here is zero trust. Everything that you're doing up here, you don't want to, you want to have confirmed authentication from everything, okay, that's machine generated. So you have zero trust up here, you have people-centric security here, everything seems to mold right in together again, okay? Other models then. Gartner has this model for the 5 styles of advanced threat defense. That's their model here. This is how it fits into the matrix. There's another one made by Scott Borg from the US Cyber Consequences Unit. If you've looked at it before, it looks remarkably the same. What I did was I took all their questions and the checklist and mapped it into the matrix to say, okay, all these different questions that they're asking, they're yes or no questions, makes it really easy to answer, and we can basically map it out against the matrix and figure out how that all fits in. All right, I have 3 more slides. Yeah, I know, I'm gonna try to. Yeah, so further work, areas for further work, trying to capture half-life, how effective this technology or process or people are for each of these different areas. Like, how often do the drivers for human behavior change? Not very often. So you don't need to change out technologies much or skill sets much there, but devices and applications change a lot more often. Being able to calculate defense in depth. How do you actually calculate the values for each of these different areas is another area for additional work. So, and then finally, just caveats. There's tons of other models out there that try to describe these phenomena. What we're trying to do is collapse them into something that makes sense across all of them. And then ultimately, what we want to do is basically say, hey, how do you falsify this model? How do you break it? Show me something, give me a vendor, or give me something that doesn't seem to fit. And it either reflects a problem with the model itself, and it breaks the model altogether, or it reflects another area that we need to extend. So with that, no time for questions, but I'll turn it over to. Yes. Yeah, and we do need questions, but yeah.